Do you get frustrated when you can't find what you're looking for when grocery shopping? Do you feel like you don't know when the store is open? Do you feel like your schedule is too booked to go grocery shopping?
1 o'clock, wallow in self-pity. 4:30, stare into the abyss. 5 o'clock, solve world hunger, tell no one. 5:30, jazzercise. 6:30, dinner with me. I can't cancel that again. 7 o'clock, wrestle with my self-loathing. I'm booked. I don't even have time for grocery shopping.
Hi, Abby Sickleseel here, and I'm here to tell you all about the robot scheduling program!
It's the future of grocery shopping. It's faster and so much more efficient than regular grocery shopping. Using this program can give the user more free time. And with 24 hours a day, 7 days a week availability, you can grocery shop any time of the day. Leap into the future with smart grocery shopping. Let's meet the team behind the program. Hi guys, I'm Abby.
Hi, my name is Michael.
Hi, I'm Jessica.
This is our honorary group member, Dan. It will first bring you to the start screen, giving you some information on the program. Then you will hit the start button. If you try to place an order with nothing on the sheet, an error message pops up. You have to first import the data from Access before moving forward. You can also clear the data and import it again. Now let's place an order. This is our grocery shopping matrix. Each white cell is a named grocery item, but let's place an order. Our first order will contain milk, spaghetti sauce, and kid cuisine. Our second order will contain filet mignon, broccoli, maple sausage, and cucumber. We don't want to order anymore, so now let's watch the robots go pick up our orders. Here is where the objects are located for each order, and this is where the robots will be traveling to.
Think about the questions to address. Might want to try to stop the fire. I wouldn't test you. I'm not the best you could have attained. Why try anything? I will get there. Just remember.
Once they have finished picking up your order, a message box will appear. You can then navigate to any sheet of your choosing. Let's take a deeper look into the code. First, we had to initialize the user form. The first item in each list box is none. The following items in each list box will grab the values from the grocery list sheet and add them to the list box. This function is grabbing the grocery list from our Access database and inputting the values into the grocery list sheet. These values are used to populate the list boxes for the user form.
Once the user clicks Complete My Order, the program starts to calculate how many items are in the order. If the list box value is not none, then the item count increases by 1, and that grocery item is stored into an array. The program will then ask if they want to order more. If they answer yes, and the number of orders is less than 5, then the user form will hide, the number of orders is increased by 1, and the user form is opened again. If the number of orders is more than 5, then an error message pops up that says they have hit their ordering limit. In the case that the user does not want to order more, then the user form is hidden and the private sub is ended. After coming out of the user form, we have two arrays. The item counts array, which contains the number of items from each order, and the orders array, which contains the strings of items from each order.
Next, we need to assign each robot to an order. We start in the first cell of the grocery shopping matrix, row 3, column 4, or D3. While the number of rows and columns is less than the number of rows and columns in the grocery shopping matrix, we will go through and see if the first item in any order is close to a robot. If so, it will assign that order to the closest robot and increase the number of assigned robots by 1. This loop will execute until all orders are assigned to the robots, and it will iterate through all of the grocery matrix. Next, we need to assign the order assign array, which contains the values of the robots assigned to the indexed order.
Next, we will call the bubble sort and return the priority array, which is the size of the number of orders. The bubble sort function is sorting the item counts array in order of greatest to least, as well as switching around the priority array, which contains the indexes of the grocery orders. Both the item counts and priority arrays needed to be reordered so that the grocery orders could be identified with their corresponding item count. The function is also switching around the orders array at the same time, which, if you remember, contains the strings of the items in each order. After the function is done sorting, control returns to the main function along with the reordered priority array.
Next, we will calculate the route order array, which contains the list of items in the order in which they should be picked up. We use this to then calculate the dist order array, which contains the distance array between all of the objects. This is based on the shortest path to the next object in the order. First, we find the distances between each object and store that into an array. Then we find the shortest path between each object and store that into an array called route order. So now this array contains the routes for each order, meaning which item will be picked up when. Next, we will need to calculate the N array. This array is very important because it now contains how the robots will get to and from each object using coordinates. If the index is odd, then it will move by column. If the index is even, it will move by row. First, we have to determine the number of columns and rows are between the starting position and the first item. We do this by calculating how far away the first object is in each order that the robot is assigned to is from the starting position of the robot in respect to the row and column. It will then store these calculations into the N array in the first two positions for that robot. Next, it will determine the number of columns and rows between each item on the list. It will do this for each robot. Finally, it will determine the number of columns and rows from the last item to the starting positions for each robot.
The N array is then used in calculating the individual coordinates for the movement of each robot. These coordinates are stored in the route array. These coordinates are calculated using the direction based on the index of the N array, an S constant that determines whether it is a positive or negative number, and uses those numbers to step through the values of the N array, making each unit move the correct distance in a straight line before it changes direction.
Thank you for watching.